In this video, we will learn how to draw the isomers of simple alkanes. The formula to find out number of isomers of simple alkanes is 2 raised to power n minus 4 plus 1, where n is number of carbon atoms present in alkane. The isomers are not possible for first 3 alkanes, that is, methane, ethane, and propane. Also, by applying the formula of finding number of isomers, the values comes to be negative for these alkanes. To find number of isomer of butane, we will put 4 in place of n because number of carbons in butane are 4. By solving, number of isomers comes to be 2. For pentane, number of isomers comes to be 3. And for hexane, the number of isomers are 5. Let's first draw the isomers of butane, which is 4 carbons containing alkane. The very first possibility is to attach all the 4 carbons in a straight chain, one after the other. The remaining valencies of carbons are satisfied by attaching suitable number of hydrogens with them, as the ending carbons has formed 1-1 bond each, while the central 2 carbons has formed 2 bonds. So 3 hydrogens will combine with each terminal carbon, while 2 hydrogens with the central carbons. This isomer of butane is named as N-butane or normal butane. The next possibility is to attach 3 carbons in the straight chain, while 4th carbon is attached as branch. In this case, there is only one possible position where branch can be attached, and that is the center carbon. As carbon has a valency of 4, so valency of each carbon is satisfied by attaching suitable number of hydrogens. This isomer is named as isobutane. The term iso is used when 1-methyl or CH3 is present as branch on second carbon. The first isomer of pentane is drawn by attaching all the 5 carbon atoms in a straight chain, one after the other. And the remaining valencies of carbon atoms are satisfied by attaching suitable number of hydrogen atoms. This isomer is named as normal or N-pentane. The next possibility is to attach 4 carbon atoms in a straight chain while the 5th one as a branch. And there is only one possibility where branch can be attached, and that is one of the 2 central carbon atoms, as both the carbon atoms are similar. The remaining valencies of carbon atoms are satisfied by attaching suitable number of hydrogens. This isomer is known as isopentane because 1-methyl is attached at second carbon. And the very last possibility is to attach 3 carbons in straight chain, while 2 carbon atoms as branch. There is only one possible position where 2 carbons can be attached as branch, that is central carbon. Now, attach hydrogens to complete each carbon's 4 bonds. The isomer is named as neopentane. The term neo is used when 2 CH3 groups are attached at the carbon number 2. The next turn is to draw the isomers of hexane. The first isomer is the straight chain. And hexane, the next isomer in which 5 carbons attached in chain and 1 as branch. There is 2 possible positions where branch can be attached. One is the carbons next to terminal carbon, and the other is central carbon. First, we will attach branch with one of the carbons next to terminal carbon. This isomer is isohexane. The next possibility is to attach the 1 carbon branch on central carbon. Another possible isomer is to draw 4 carbons in straight chain and 2 as branch, 1 on each central carbon. And the very last isomer is to draw 4 carbons in straight chain and 2 as branch. But this time, both branches are attached on same carbon. This isomer is named as neohexane